Okay, this is IM1. This is lesson 5-1. This is on page 285. We're doing Got It problem 2. So it's asking us to make a simplified form, which basically means positive exponents. So if we look at A, we have x to the negative 9th. Whenever we see a negative exponent, we know that we need to switch it to the other side of the fraction line. All right, so right now it's in the numerator. So let's switch it. Now let's put it in the denominator. We switch it to the other side and we make the exponent positive. This one is a great example of why we don't just generalize, because right now it's a negative exponent in the denominator, right? So to fix it, to simplify it, to make it a positive exponent, we need to put it in the numerator. If it makes you feel better, you're welcome to put a over 1, but that's sort of implied and you don't need to add that in. All right, so let's look at multiple things. In C, we have 4c to the negative 3b. That means that this one and this one are where they're supposed to be, and this one needs to be switched. So right now, all of them are in the numerator. So let's leave 4 and b in the numerator because they can stay put, and c to the third goes in the denominator. All right, when we look at D, we have 2 in the right spot, but a has a negative exponent, so we need to flip it to the other side of the fraction line. So we're going to end up with 2a to the third. If we come down to E, we have n to the negative 5, and we have over m squared. This one is fine. It can stay, right? It has a positive exponent. This one has a negative exponent, so we need to switch it. So we're going to have 1, because that's all that's going to be left, over n to the 5th m squared. It doesn't matter which one you put first because it's multiplication. You could also say 1 over m squared n to the 5th. All right, if we take one more second and we do the practice problem 4, I'm going to use red to mark which ones need to stay put. This one can stay put. This one can stay put. This one can stay put. That means that this one and this one need to switch to the other side of the fraction line, right? So we have 7. S to the 0 is just 1, so we can actually get rid of it, right? That's just going to be equal to 1, so it can disappear. We're going to move the 2 up to the other side, 2 to the first. I'll put the 1 in and simplify this in just a second. And then over t to the 5th, because that needs to switch to the other side, and m squared. All right, just to simplify the top, we have 7 times 2 times 1. So we have 14 over t to the 5th m squared.